आ रही है MS वर्ड की स्क्रीन? क्वेश्चन भाई जवाब तो दे दिया करो ताकि मुझे पता तो चले।
यस सर।
जी नजर आ रहा।
ओके नाउ अब जो हमारा सेकंड क्वेश्चन है ये असाइनमेंट है, आपने देखा भी होगा। तो ये तो मैं नहीं करा रहा, ये असाइनमेंट का क्वेश्चन है, ये आप लोग खुद ट्राई करेंगे। असाइनमेंट जमा करने के बाद फिर जो है ना मैं खुद इसका सोल्यूशन अपलोड कर दूंगा ग्रुप। इसी तरह जो थर्ड क्वेश्चन है ये बहुत आसान है, सर ने एक एग्जाम्पल कराई थी, इस लेक्चर नोट्स में भी है वो एग्जाम्पल, सेम वैसे ही ये बात। ये रिकर्सिव सीक्वेंस है या इंडक्टिव कह लें सीक्वेंस है, तो इस सेम इसी पैटर्न पे वो चलेगा, तो बहुत मतलब जस्ट मैथमेटिकल वर्किंग है वो, उसमें कोई कॉन्सेप्ट वगैरह का यूज नहीं है। तो ये वाला आप तो खुद ट्राई कीजिएगा, वरना मैं इसी सोल्यूशन के साथ इसका सोल्यूशन भी अपलोड कर दूंगा। ओके सो ये वाला क्वेश्चन जो है हमारे पास फोर्थ इम्पोर्टेंट क्वेश्चन है, ये देखें। स्क्रीन क्वेश्चन 4 एक्सरसाइज का। अच्छा उसमें हमें क्या करना है कि वो कह रहे हैं कि हमारे पास एक एक्शन है, ये हमें गिवन है, एक्शन इस, ये एक्शन हमें इंडक्टिव सीक्वेंस है, जिसकी डेफिनेशन क्या है, डिफाइन बाय, यानी उसकी टर्म किस तरीके से डिफाइन है कि x equals to 1/1 square plus 1/2 square plus 1/3 square so on 1/n square। अब ये कह रहे हैं कि शो करो कि ये जो एक्शन है ये बाउंडेड भी है, ये जो एक्शन है सीक्वेंस एक्शन, सिर्फ इसकी टर्म में बताइए, सीक्वेंस एक्शन जो है वो इंक्रीजिंग है एंड बाउंडेड। ओके सो एनी आइडिया, किसी पार्टिसिपेंट को, किसी स्टूडेंट को कोई आइडिया है कि क्या कर सकते हैं? एनीवन? जीरा कोई आइडिया है क्या करना चाहिए? किसी को कोई आइडिया है? ओके सो सबसे पहले हम ये प्रूफ करते हैं कि एक्शन जो है, सबसे पहले एक्शन को इंक्रीजिंग शो करें, एक्शन इज इंक्रीजिंग। ओके तो इंक्रीजिंग के लिए अगेन हमें पता है कि किसी भी टर्म को इंक्रीजिंग शो करना हो तो हमें क्या करना होगा, वही के एक्स एन प्लस वन को, या ऐसे लिखने एक्स एन को लेस देन इक्वल टू दिखाना पड़ेगा एक्स एन प्लस वन, यानी ये चीज शो करनी पड़ेगी। ठीक है, ये हमारा क्लेम है, दिस इज आवर क्लेम। ओके ना, तो हम बाय इंडक्शन ही से शो कर देते हैं, बाय इंडक्शन। तो बाय इंडक्शन क्या है, 4n इज इक्वल टू 1। अच्छा, n इज इक्वल टू 1 के लिए क्या हुआ कि ये n की जगह 1 x1 और x1 प्लस 1 विच इज x2। तो अब हमें शो करना है कि लेस देन इक्वल टू है या नहीं। तो हमें पता है x1 क्या हो जाएगा, जस्ट 1 ओवर 1 का स्क्वायर, इस तरीके से डिफाइन है सीक्वेंस। और x2 जो है वो 1 ओवर 1 स्क्वायर प्लस 1 ओवर 2 स्क्वायर। तो हम देख सकते हैं कि ये वाली चीज और ये चीज से बड़ी है। फॉर n इज इक्वल टू 1 के लिए तो कोई इशू नहीं। असल वर्किंग अब हमें क्या करनी है कि हमें अज्यूम करना है कि दिस इज ट्रू फॉर n इज इक्वल टू k, और फिर k प्लस 1 के लिए प्रूफ करना है। तो मैं लिख लेता हूँ अज्यूम, हमारा जो क्लेम है इज ट्रू, एंड ट्रू फॉर व्हाट, ट्रू फॉर n is equal to k. So it means I can write x of k is less than equal to x of k plus 1। हमें ये अज्यूम करना है, ठीक है। So we have to prove now, प्रूफ क्या करना है कि x k प्लस 1 लेस देन इक्वल होगा x k प्लस 2। ओके, so what we did, we just start with x of k plus 1 which is equals to, by definition given in the question, 1 over 1 square plus 1 over 2 square plus 1 over 3 square, so 1 over k plus 1 का होल स्क्वायर। Okay. Now this thing we know is less than equal to if I add something on the right hand side, plus 1 over 2 square plus 1 over k plus 1 whole square, k plus 1 square plus 1 over k plus 2 का whole square. So what I did here, I just add this term over here in the right hand side, so which make this side is greater than to the left hand side. Okay, so yeah, now we know okay this thing, the definition of x of k plus 2, it means this implies that x of k plus 1 is less than equal to x of k plus 2, and this is what we want to prove. So this completes the proof that xn is increasing. Now we are going to move forward, and second we have to prove xn is bounded. Okay, so for boundedness we have to give in some, you can say, hint in a question. I can share with you this thing. This hint is given in our question that if k is greater than equal to 2, then 1 over k square is less than equal to this thing. So let's forget about this hint, and I just prove you how we take this hint. Okay. You have some intuition why they give us this hint, not any other. Okay, so just take this term k into k minus 1, k into k minus 1. This thing equals to, when I multiply the outer k binary terms through k square minus k into 1 is k. Okay, and this thing k square minus k, this thing is less than equals to k square, because this, if I neglect this minus k, so I got this inequality, but this hold for k is equal to greater than equal to 1, not for all, because if I write 0 and 0, so minus 1, and here 0 the 0 minus 0 is 0, so minus 1 equals to 0. So this thing not holds for 0 and less than 0 thing, 0 numbers. So this inequality holds just for k is greater than equal to 1. Okay, and when I divide them or I reciprocal this inequality, what should I get? 1 over k, k minus 1, now greater than equal to k square. The inequality flip, right? But if I write 1 here, so I get 1 over 0, which is infinity. So what I write, that this inequality hold for now for k is greater than equal to 2. Okay, this thing is understandable to all, right? Any question? Anyone have any query about this step? Sahar Abbas, do you understand?
1 over k square नहीं होगा?
1 over k square.
1 over k
Oh,
square.
yeah. This should be 1 over k square. Sorry, it's my mistake. Yes, 1 over k square. Okay. So what we did now? So 1 over k square is less than equal to 1 over k, 1 over k, k minus 1. Okay. And by partial fraction, okay, so I have to skip this step. Okay, अब ये partial fraction कैसे हो रहा है, आप लोग खुद भी देख सकते हो. 1 over k square is less than equal to, अब जब हम इसके partial fraction करेंगे इस टर्म का, yes, तो what we I get 1 over k minus 1 minus 1 over k. तो ये छोटा सा होमवर्क समझ लें, बट ये इजी है, बहुत इजी, अब आराम से कर लें। ओके, तो ये हिंट हमें गिवन है बेसिकली, और मैंने इसे ड्राइव कर दिया है कि क्यों गिवन है, ये अब हमें आगे पता लग जाएगा। सो हमें बाउंडेड दिखाना था एक्स के, या आप कह लें हमें एक्स एन को बाउंडेड दिखाना था। वी हैव टू शो दिस दैट एक्स एन इज बाउंडेड, राइट? दिस इज आवर गोल. So what does it mean to show that some sequence is bounded? This means that every term of xn should be less than or equal to some number, every term. So we have to show every member of this term less than equal to some number. So what is that number, or you can say what is that bound that we have to find. Now, so let some arbitrary term xk, and we have to show that this term is less than or equal to some number, some real number. So by definition xn is 1 over square 1 over 2 square plus 1 over 3 square plus so on 1 over k square. Okay, so now this hint help us to solve further. How? Okay, so 1 over 1 square, we know this is 1, plus this term 1 over 2 square. So we use this thing, that is our hidden question, that 1 over k square less than equal to this. If this is important, if k is greater than equal to, okay, so 1 over so I can write 1 over 2 square as 1 over 2 minus 1 minus 1 over 1, right? But now this thing should be less than equal to. This inequality appears. Okay. Plus, what about 1 over 3 square? We again use the same thing, 1 over 3 minus 1 minus 1 over 3. Now for 1 over 4, we have 1 over 4 minus 1 minus 1 over 4. And it's going on. So what we get in the end is this 1 over k minus 1 minus 1 over k. Okay, so let's simplify this further. This thing. Okay, so let's start. हमने कहाँ छोड़ा था? Okay, so this thing equals 1 plus, now simplify it, 1 over 1. Okay, this should be 2. So I did a mistake here. This is 2. Okay, so minus half plus 1 over 2 minus 1 over 3 plus 1 over 4, 3 minus 1 over 4 plus so on plus 1 over k minus 1 minus 1 over 3. Okay, and this thing is equal to 1 plus 1 minus half plus half minus 1 by 3 and so on. So you think you can easily see that this 1 over 2 here with minus sign, this is cancelled with this, and this 1 over 3 plus is cancelled by this 1 over 3 of minus sign. So we just left with these terms. This is just the first one, the second one of the bracket term, and the last term minus 1 over k. All the other things should be cancelled. So what we get, we get 1 plus 1 minus 1 over k. And we know if we, okay, so 1 plus 1 is 2, and if we neglect this term, so this inequality preserve. So this means that the term xn is less than or equal to 2, and we take this xn as an arbitrary sequence, right? So it means any member of the sequence xn, any term xn less than and equal to 2. So this is the bound. This is the upper bound of our sequence, and we know lower bound is, what is the lower bound? What is the lower bound? Anyone? X1
1.
1, right? Because x1 is 1 over 1 square, which is 1. So this is the lower bound, and this we find out the upper bound. So the any sequence which has lower bound and upper bound, we know it is bounded. So this proves our claim that our sequence is bounded.
सर प्लीज लास्ट 2 स्टेप्स रिपीट करें.
Okay. Last 2 steps. This one. This step.
नो लास्ट में आप नीचे आ जाए. हाँ 1 plus 1 minus 1 over k और जो लास्ट में किया है.
So what we did here is, yes, so we find out that only these 3 terms are left, 1 plus 1 and minus 1 over k. So 1 plus 1 is 2, right? And okay, so I can do one more step which is in between these 2 steps. 2 minus 1 over k, and 2 minus 1 over k must be less than equal to and equal to 2, right? Because if this is some positive term which you subtract from 2, so if you didn't subtract it from 2, this must be greater than 2. Like if we neglect this term minus 1 over k, so it means that this is greater than 2 minus 1 over k. Uh, I hope you understand, right?
Yes.
Okay. So in the left hand side, in our first step, we have xn. So it means whatever calculation we did for xn, it make xn less than equal to 2, right? So it means that every member of the sequence is less than or equal to 2. Okay, let's move further. And again, let me share with you my word screen. Okay, here it is. Now, again, question number 5, important question. Let a is greater than 0, prove that the sequence. Okay, so let me write this first. Right. Just a minute. Okay. Question number 5. So A, we have a number A which is greater than 0, and we have to prove sequence under root A, second term is A plus under root A, third term is okay, under root A plus under root A, and in this there is another under root, and so on. So this is our sequence, and we have to show that first that it is convergent. First thing is to prove it is convergent, and the second is we have to find its limit. So okay, what we did here, we use our monotonic convergence sequence theorem, which says that if we have a convergent sequence or if we have a bounded monotonic sequence, so it must be convergent, and this is by implication. So it means if the sequence is convergent, so it must be monotonic, increasing or decreasing, and bounded as well. So we have to prove convergent. So what we did, we first proved that this sequence is monotonic, and by monotonic we mean either monotonic increasing and monotonic decreasing. So first step is to prove that this sequence is monotonic, and we have to decide that it is monotone increasing or decreasing, so we can check it also. And second thing, we have to prove it is bounded. So when we prove these two things, it means we can apply our monotone convergence theorem. I write it here in a abbreviated form. So which make sure this theorem guarantees that this sequence is convergent. So we have to do two things here. First, we have to prove this sequence convergent. Second, we have to find its limit. So for the first thing, For the convergence part, we have to prove two things, monotone and bounded. So let's find out if this sequence is monotone or not, or whether if it is monotone, so it is monotone increasing or decreasing. So okay, before this, let me write this sequence in this form. Okay, so first I name it this sequence. So let's call it y of n. Let's name it y of n. Okay, and what the second or alternative form of this sequence is this, then y1 is under root a and y of n plus 1 is under root a plus yn. So what I did, I write inductive form of our sequence. It means that y of n plus 1 is a function of yn, and you can a plus 1. I hope no one has problem for this form. If you guys have any question, you can ask. That we can write our given sequence in this form, and you can check easily that if you write n is equal to 1, so 1 plus 1 is 2. So it means this is a f of 2, y of 2 is a function of f of y1, which means a plus y1, and we know what is y1, it is given already, a plus y1 is under root a, so we get second term. Likewise, we find out third, fourth, and so on and so forth, every term by this formula. So this is important, that our sequence is written, it can be written in this way, and we can easily see it is inductive sequence or recursive sequence. So now let's start our working. So first we have to show monotonicity, that this, sorry, monotonicity. And by monotonicity we mean it is either increasing or decreasing. My claim is that our given sequence is monotonic increasing. Monotone increasing. So how did I find that it is monotonic increasing? Remember, in every question it is compulsory that you find 2 or 3 terms of every given sequence, so you can find out it is increasing or decreasing, like I can did. Okay, so why? The first question is why I said it is monotonic increasing, not decreasing. And you have to do these steps in every question. सर आपको पेपर में या क्विज में किसी में भी वो देते हैं, तो आपने जब पहले मोनोटोनिसिटी चेक करनी है, जिसमें मोनोटोन इंक्रीजिंग और डिक्रीजिंग चेक करना है, तो सबसे पहले आप 1-2 टर्म्स को चेक कर लें, उनकी वैल्यूज रख के कि आइदर इट इज इंक्रीजिंग और डिक्रीजिंग. सो वी नो y1 is under root a and y2 is a plus under root a. Here a is greater than 0. That's why root is possible here, because we are talking about real numbers. And we know in our algebraic when we study about algebraic properties of real numbers, we know if a is less than equals to b, this by implications hold. What is the implication? Root of a is root of. Okay, so this implies this is root a this must be less than equals to what? A plus, okay, so just write it here, A. So A is less than equal to A plus root A, because this is some positive number. When we add some positive number, so this must be, this inequality must be hold that this term is greater than this term. And when you apply root of A is less than equals to A plus root of A. Means that root is an increasing function. If A is less than equal to B, it means root A is less than equal to root B. So it means that root A or y1 is less than equal to y2. And you can check for y2 between y2 and y3 as well. The same, by this same argument, you can say this thing is less than equal to. So this is our intuition, but we have to prove it mathematically, right? तो हमारे को इंट्यूशन तो मिल गई कि ये मोनोटोनिक इंक्रीजिंग होगी, but how can we show this? So our claim is yn is increasing or monotone increasing. Monotone increasing. And what does it mean by monotone increasing? So we have to show this y1 is less than equal to y2 which is less than equal to y3. जिसे बाय इंट्यूशन तो हमने देख ही लिया है कि भाई लूट की प्रॉपर्टी की वजह से हो रहा है, या सिंपल ऐसे लिख सकते हैं yn plus yn must be less than equal to yn plus 1. So this is our claim. So we use again induction for this, and right, we prove it by induction. Proven by induction, right? So for n is equal to 1, this is the procedure of induction. We have to show that the claim is whole, or you can say the claim is true for n is equal to 1. So for n is equal to 1, we have to show that yn is less than equals to yn plus 1, and y1, because n is 1 here, we have to show that y1 is less than equal to y1 plus 1, which is y2. So y1 is a and y2 is a plus root a, and this thing implies because under root is increasing function. Under root is an increasing function. So this must be whole, which implies y1 is less than equal to 1. So for n is equal to 1, it is very easy. What about next step? So for this, we have to assume that claim is whole for n is equal to k. What does it mean? That we assume that y of k plus y of k is less than equal to y of k plus. Okay. And we have to show so we take this as an assumption, and by using this we have to show that claim is true for n is equal to k plus 1, which is nothing but we have to choose this thing, i.e. that y of k plus 1 is less than equal to y of k plus 2. This thing we have to. All right. So for this, what we have given, जो हमें गिवन है हम वो लेके चलते हैं. हमें गिवन है कि y of k less than equal to है y of k plus 1 के. ओके, तो y of k plus 2, y of k plus 2 किसके बराबर होगा? हमें सबसे पहले तो पता है वो f of y of यानी फंक्शन होगा k plus 1 का. हमने ऊपर डेफिनेशन इसी तरीके से डिफाइन की थी, विच मीन्स के वाई के प्लस 2 फंक्शन है वाई के प्लस 1 का, यानी a प्लस वाई ऑफ के प्लस 1, ऐसे ही होगा. अच्छा, ये जो डेफिनेशन है ये तो y ऑफ k की डेफिनेशन है k प्लस 1 के लिए. दिस मीन्स के ये चीज बड़ी होगी f ऑफ y k से, यानी y ऑफ k प्लस 1 से. तो इसका मतलब क्या हुआ कि y ऑफ k प्लस 2 ग्रेटर देन इक्वल्स टू y ऑफ k प्लस 1, or you can write it in this way as well. And this is the thing we have to show. Any question, any problem, any query regarding these steps? Anyone? I hope it's clear to all of you. Faizan? Are you there, Faizan? I think he is not there. So, Rumesa, are you there?
Yes,
Rumesa? So, any problem? Any issue? Ali Haider?
Yes, sir.
Okay.
No issue.
ठीक है. So it means we have proved that our sequence is monotonic increasing. Now our second step is for boundedness, and we see in our lecture that if sequence is increasing, so we have to just prove that this sequence is bounded above, right? Because we already know the lower bound, which is root a. This is the term from where our sequence start, and our sequence is increasing. It means that this should be the lower bound, and every other term must be greater than this value. So now we have to find what is upper bound. So, upper bound, right? So what does it mean to show that the sequence is bounded? It means that every member of this term yn is less than or equal to some number, call it n or something else. We have to show this, that every number of this sequence, every member of this sequence, which is yn, the absolute value of this number is must be less than equal to some other real number and by this we show that our sequence is bounded. So for this we have another hint. Okay, so this is our claim, right? We have to show yn is bounded. This is our claim here because we use induction again. So we have to first specify, we should have to specify that what is the claim. So this is the claim, and I polish this claim as further that yn is bounded by 1 plus 2 root a. Okay, so this is our this sequence is bounded by this term. This is our claim. I have to prove this, but the question arises, where do I get this 1 plus 2a? So the first answer for this is that this is also given to you as a hint, as like we are given in our previous question, but I can show you from where we get this at the end. And you can guys always have this intuition that before starting monotonicity proof and converge point boundedness proof, sir first find out the limit, and sir said that this is the last step. Sir did this step in first because क्योंकि सर ये चाह रहे थे कि आपको जैसे इंट्यूशन हो जाए कि नंबर आता कहाँ से, तो बिल्कुल इसी तरीके से। तो वो अभी हमें एंड में जब हम लिमिट निकालेंगे तो तुम्हें पता लगेगा कि 1 plus 2 है, यही बाउंड क्यों आ रहा है। ओके, तो अभी का क्लेम ये है कि वाई एन बाउंडेड है 1 plus 2 अंडर रूट ए से, और ये प्रूफ करना है, यानी इसकी हर टर्म इस नंबर से बाउंडेड है। तो फॉर एन इज इक्वल टू 1, okay, so y1, what is y1? y1 is under root a, and we know that under root a is less than 1 plus 2a. For n is equal to 1, it is obvious. Now assume for claim is hold for n is equal to k. What does it mean? That y of k is again less than or equal to 1 plus 2 root a. So, and what we have to prove, that we have to prove that if this claim is true for y of k plus 2. So it means y of k plus 1. So y of k plus 1, y of k plus 1 किसके बराबर होगा? By definition a plus और अंदर yk, राइट। और अगर मैं इसके अंदर y of k की, क्योंकि हमें पता है कि y of k, अभी हमने अज्यूम किया हुआ ये कि y of k इस टर्म से बाउंडेड है। तो व्हाट डज इट मीन बाउंडेड है? इसका मतलब है कि अगर मैं अंडर रूट a और वाई के की जगह पर 1 plus 2a रख दूं, 2 अंडर रूट a, तो ये वाली चीज आ जाएगी, क्योंकि y के से बड़ी है ये चीज। तो मैं y के की जगह ये रख रहा हूँ, इसका मतलब है ये टर्म इस प्रीवियस टर्म से बड़ी हो जाएगी। ओके, और ये वाली चीज अगर आप देखें तो ये फार्मूला किसका बन रहा है? a अंडर रूट a प्लस 1 का होल स्क्वायर। अंडर रूट a प्लस 1 के होल स्क्वायर को आप खोलें, यही बनेगा a अंडर रूट a का स्क्वायर a एंड 2 अंडर रूट a इंटू 1 और प्लस 1 का स्क्वायर। सॉरी, प्लस 1 का स्क्वायर। यही चीज गिवन है, तो मैं इसे ब्रेक कर देता हूँ, यानी फॉर्मूले में क्लोज कर देता हूँ। अंडर रूट ए प्लस 1 का स्क्वायर, स्क्वायर कैंसिल, अंडर रूट ए प्लस 1। अब अंडर रूट ए प्लस अगर मैं 2 से मल्टीप्लाई कर दूं, 2 अंडर रूट ए प्लस 1, तो क्या होगा? ये साइन आ जाएगी। इसका मतलब है कि y ऑफ k प्लस 2 k प्लस 1 लेस देन इक्वल टू 2 अंडर रूट ए प्लस। तो हमने y k के लिए सपोज किया कि y k इससे छोटा है 1 प्लस 2 अंडर रूट ए से, और उसको यूज करते हुए हमने ये बता दिया कि y k प्लस 1 भी इससे छोटा है। इसका मतलब है कि सीक्वेंस की हर टर्म इस नंबर से छोटी है। दिस इम्प्लाइज, हम क्या फाइंड आउट कर सकते हैं? दिस इम्प्लाइज के वाई एन जो है हमारे पास इज बाउंडेड। ओके, तो हमने बाउंडेडनेस भी पता कर ली और मोनोटोनिसिटी भी पता कर ली। तो अब हम थ्योरम यूज कर सकते हैं, क्योंकि अब ये बाउंडेड अबव भी है और इंक्रीजिंग भी सीक्वेंस है, तो इसका मतलब ये कन्वर्जेंट होगी। बट कन्वर्ज करेगी किसको? व्हाट इज द कन्वर्जेंट पॉइंट, और इन अदर वर्ड व्हाट इज द लिमिट पॉइंट, लिमिटिंग वैल्यू क्या है? सो फॉर दिस what we did, we take our definition of sequence y of n plus 1 is equal to under root a plus y of n, right? Taking limit on both sides, what we get is this step, which is limit n tends to infinity y of n plus 1 is equals to limit n tends to infinity under root a plus 1. Okay, what's the next step? So limit of y n tends to infinity y plus 1 as it is रहेगा, and here limit should get inside, which is limit of n tends to infinity of 1. Okay, so now let that this thing, the limit n tends to infinity, वो कैसे हम ये let कर रहे हैं, y of n कोई भी नंबर है l, right? So by tail of sequence theorem, what we get? Limit n tends to infinity y of n plus 1 is also, यानी अगर y n की लिमिट n l है तो y n plus 1 y n plus 2 सबकी लिमिट जो है वो l होगी। ओके, सो विच मीन्स दैट इसकी भी लिमिट l है और ये जो इनसाइड टर्म है इसकी भी लिमिट l है। व्हाट वी राइट, l is equal to under root a plus l, दोनों जगह पर स्क्वायर ले लें तो a प्लस l which is l square minus l minus a equals to 0. Okay, now okay, तो अब आप इसे सॉल्व कर लें। l is equal to minus b, तो माइनस ऑफ माइनस l प्लस माइनस अंडर रूट b स्क्वायर यानी माइनस l स्क्वायर माइनस 4 a is 1 c is minus a divided by 2, right? So l is Now limit is it is 1 okay, -1 plus minus 1 plus 4a divided by 2. So we have two terms for the limit, but by uniqueness theorem we know that there is, if the limit exists, it should be unique. So we have to L1, which is plus 1 is plus 1 minus under root 1 plus 4a divided by 2, and L2 is 1 plus 1 plus 4a divided by 2. ओके, सो बट हमें पता है कि हमारी जो लिमिट होगी वो ये पॉजिटिव वाली होगी, ठीक है। अभी हमने देखे हैं कि जो हमारी सीक्वेंस है वो पॉजिटिव है, तो सीक्वेंस है हमारी अंडर रूट है, क्योंकि ए 0 से बड़ा था ना, ए तो 0 से बड़ा था, सीक्वेंस थी हमारी रूट ए प्लस रूट ए, तो ये भी ग्रेटर देन 0 ग्रेटर देन 0। जब सारी टर्म ग्रेटर देन 0 है तो जो उसका लिमिटिंग पॉइंट आएगा तो हमें पता है उसकी लिमिट भी ग्रेटर देन 0 होगा, तो इसका मतलब है for any value a greater than 0 this should be our limiting mass, and by this we get our this term 1 plus 2 under root a, which I use as a boundary. So just a manipulation of this thing. I hope it's clear to all of you. Okay. Now, okay, this meeting का भी time end हो गया है. Should have stop recording.